Okay, so let's start. And before actually going further, I would like to ask yourself these two questions. I will also answer them during my talk, but let's say answering the first question, who is a Java developer here? Okay, cool. And who is a senior developer? Oh, even better. And perhaps some architects? Impressive. Wow, that's cool. So, why I am here? Just I answer this question in advance. I just want to share my experience in working in science field and applying enterprise technologies to solve, let's say, scientific tasks. So answering the first question, if you go to my personal website, you will quickly find out I'm a software developer. So this is me, and I'm a software developer. And here are some facts about me. So I've started from the JavaScript field at 2007. And then 1 year later, I switched to Java and web development. I'm doing full stack development since 2012. And 1 year later, I had to learn C++, as I already worked here at DESY. And since last year, I'm a Tango kernel developer. So my talk will be organized in this direction. So from the backend to front end, and on the back end, we actually talking about Tango. So what is Tango? Shortly speaking, it's an open source framework. It's a which allows you to implement SCADA systems. So SCADA means system control and data acquisition. And if we talk a little bit about history of Tango, it's all started here in Europe, specifically in Grenoble at ESRF facility, which is synchrotron facility. And as almost any synchrotron, it has this nice concrete ring. And if we look inside this ring, we see a bunch of hardware. There are position monitors, vacuum monitors, vacuum pumps, different motors, magnets, and so on. And on the other side, we have a control room where people sitting in front of this, in front of displays and looking onto this nice GUI application, which basically gives them an idea how the system is running, so how it performs, how it's healthy. And what is Tango? Tango is a thing that actually glues the hardware and these GUIs. So imagine we have different computers running different operation system, and to these computers we connect different hardwares. And actually Tango provides a unified interface for all these devices, so we can easily, on top of it, build different applications. And this is a screenshot from the Tango website documentation. And what I would like to stress now is this abstraction idea of Tango. So each thing resides in a so-called device server. It's like, well, basically it's a process in an operation system, and then each device has number of classes or maybe single class. Here it's basically a class the same as in terminology of object-oriented languages, so it's a meta description of the device. And then we have devices, which again, if we use analogy to object-oriented languages, devices are concrete instances of the device classes. And each device has attributes, commands, pipes, and pipes. And this is the most important to for further understanding of my talk, because everything spins around these attributes and commands. Another important concept is Tango-Host. Tango-Host is a database which contains data services. So if client comes to Tango and says something like, okay, I want to interact with this motor to move it. So first thing he has to do is to consult Tango-Host for exact address of that device. And then client can interact with the device peer-to-peer. So let's back to where we are. And basically we are at DESY. So DESY is also a synchrotron. So it's an acronym of JUGHH synchrotron. And as you can see, we also have a concrete, well, not the whole ring, but a segment of it. By the way, we are sitting in this building here. So you can imagine the scale of the facility. And inside this concrete ring, we have beam lines, this thing here. So we have a line from the storage, which ends up in a so-called instrument. So instrument is a bunch of hardware which performs some scientific experiment, for instance, tomography. And now I'm close to answer the second question, which I asked in the very beginning to myself, so why I'm here. I was hired by Helmholtz-Zentrum JUGHH a couple of years ago to develop a control system environment for the beamline. So Helmholtz-Zentrum JUGHH operates several beamlines at DESY. And here on this big picture, you just see a high-level overview of the system. So technically, it consists of a bunch of software components that performs basically two tasks. So the first one is to give a user and beamline scientist is a kind of operator of the instrument or experiment hardware, and a convenient interface to the hardware to operate it, to describe the experiment. And another task is to collect all the data and then put it into some final storage where it can be accessible for further post-processing and scientific approaches. So today I will mainly focus on, no, not mainly, well, I will focus on this part and specifically on a single application, web application, which allows our beamline scientists through web browser to monitor and control the hardware. On this print screen, I give you just an overview so you can realize what is going on here. On the left-hand side, we have a tree of all the devices involved in the experiment, so in the instrument. And if we choose one of the devices on the left-hand side, we have a table view which gives us values of the attributes in real time, maybe highlighting some of them if we configure some warning levels or alarm levels for the values. We also have a so-called device panel where we can execute commands, read attributes, read-write attributes, read-write pipes. We can build images from data coming from the detector. So in case of tomography, these are normally cameras. We can plot spectrum values and so on. So this just a presentation of the application, and I believe being a developer, you can imagine how much effort does it take to develop something like this. Well, not much actually, and I will focus on it later. So now I switch from the backend part to the middleware, but before doing this, I have to say that if you come to a scientific field, or maybe any other field, but anyway, sometimes you end up using libraries with this API, and this bunch of code is just to read a single value from a device. So as you imagine, when you see this code, you are stressed, because you realize you have to write it a lot of times and you don't want to do it. And actually what I did, I wrote a facade API for this API, so then we can read attributes, for instance, attributes in a very easy manner. And this gave us a very nice building blocks for further development. I will refer to it later. So just to compare, so instead of this, we just write two lines of code. And another thing when I came to the Tango world is that it had no web interface at all. So what was the decision? I decided that it might be interesting for Tango community to have a REST API specification. And this is what I did. I proposed a REST API specification, and then Tango community had a feature request to define the standard, so any institutes that run Tango can use their own implementation or write clients for the REST API. And nowadays, REST API becomes very popular in the community. So as you might see, it was quite hot discussion comparing to the other topics. But in the end, in August of last year, the specification became more or less stable. So we have now a GitHub repository with the specification and some compatibility tests in Maven project. So everyone who wants to develop their own implementation or their own client can run this test and be sure that they are compatible with the official version. And this is very nice because it's only a specification, so I want to stress this. It's only a specification of API without any implementations, and if you read it, it's just a request and response. In a request and response manner described what you expect from the server and what you're allowed to ask. So when we have these building blocks like facade API and REST API specification, we can actually switch to the middleware and to implementation of our server part of our application. So from the bird fly point of view, it's a standard Java web application running in Tomcat, which uses JUGHH RS and specifically REST easy implementation to implement REST API. And on the front end, obviously we have a web client speaking HTTP to our server. On the back end, it speaks to the Tango bus and then to the hardware. And it also has a two-step authentication. So the first one is it consults Kerberos for the valid, if provided username and password pair are valid. And then it also asks Tango access control whether specified user is allowed, for instance, to read the specific attribute or execute specific command and so on. So it's quite safe. I don't want to dig really deep into the implementation of the server, but rather I just will highlight several features which I find interesting in our server. So namely binary cache, object model, image handling, and response fields filter. So let's start with the first one. Why we need binary cache and what it is actually. So as you might know, in response you can define a response cache header, and so that if your browser asks for the same thing twice within the period of time defined in this header, it won't actually even ask the server for a response. It just will take the value from the cache and give it to you immediately. So this idea is the same, but to prevent multiple requests of the same stuff to the hardware. So if we read a position from a motor, it probably won't change in next 200 milliseconds, and if another client will ask for the same, we just give the stored value. So how it's implemented? It's very easy. In fact, it's just a servlet filter, which basically, if we have a GET request for something and we do not find it in cache, we create an entity using the cache response wrapper. And what cache response wrapper is doing is that it stores the copy of the response as a byte array. So if we hit the cache, we basically return a byte array. So we directly write it into the output stream and prevent further execution of the request on the server side. So for our needs, it's very easy and powerful concept, and we are really happy with it. And so switching to the next point I would like to highlight is the object model. So as you might remember, I just described the Tango. Tango has, the central thing in Tango is device, and each device has attributes, commands, and pipes, and so on. So this maps perfectly into the JUGHH REST specification. So we have a, let's say, device resource on our server side, which has device attributes, so that we return an instance of device attribute, which is in turn resource, REST IP resource. And if we want to read the value from the attribute, we simply make a proxy call. Again, I would like to highlight this single line because otherwise it would be this bunch of code, you remember, if not the facade API. So very elegant and nice solution, and this helps us to keep code very clean and understandable, because if you know the concept of Tango, you can easily recognize what is going on in the code of our web server. So next point is image handling, and basically we are talking about embedding images into response. So why we are doing this? At this point, you might ask yourself why I'm so much asking myself why. Well, it's because I like to justify my actions. And for this, there are 2 points. So the first one, we do a single request response sequence instead of 2, because normally if you ask for an image, someone would generate it on the server and then give you a link, so you ask for the image in the next request and so on. Here we just give an image in the first run. And on another minor thing is that we do not require users to add these authentication headers to the request, because in our application we rely on basically it's HTTP authentication. So when users reach the protected region, there is a pop-up built in the web browser. They provide the username and password, and all other subsequent requests to this protected region are supplied with these headers automatically by the browser. If we need to load an image, we have to make a manual request and provide these headers manually. So this also saves us a few lines of code on the client side. So how this is implemented? Again, quite easy. In the JSON, so we use JSON together with REST to produce JSON responses. We have a Tango image sterilizer, which basically doing 2 things. So the first one, it takes an image and then it writes it into the response using the Java image framework. Well, the thing here is that we have to produce this temporary string, because if we try to write this byte array directly into the response outstream, there was an exception, and I had no really solved this. So maybe if you ever encountered with this, I have a solution for it. Would be nice to get away from this temporary string object. And how it's getting image? Well, again, it's quite simple. We are using our facade library. The beauty of this is that, imagine, so from the hardware you get a bunch of integers usually. So it's an image, like 4K per 4K. And if you use Java image framework directly, so you create a new instance of buffered image and you look inside the constructor, you will see that there is a copy of the original array being made. So and our library just creates a buffered image without copying. So it takes a reference to the data and then wraps it with a buffered image instance. Okay, that was not really that easy to find out how to do it properly, but in the end, you see it's very fantastic and clean and easy code, and it's really gave us a significant performance gain on the server side. So the last thing I want to talk about the server side is a response fields filter. So in our specification, community desired such a feature that, for instance, you ask for a device information, but you only want a name and say server fields in the response. So you filter out all other stuff to, let's say, reduce the bandwidth. So here you can see that complexity of the request is that you have to preserve the layout of the object. So if there is a requested field somewhere deep in the object hierarchy, then you have to return it anyway. And another request was that, well, it's basically opposite. We want something, but we don't want, for instance, info properties. So the response should look like this. So it contains anything except these fields. And if we look onto the implementation, again, in Jackson configuration, when we are creating a context of the request, there is a filter somewhere defined before in the chain. And if it's inverse, I mean, if we want fields that are not expect provided, then it's extremely simple. We just say to the rest easy, okay, here's a take this filter and serialize everything. For the opposite, we had to implement our own function, but again, it's quite straightforward. Basically, it iterates over the fields and see if the fields is in the desired array, then serialize it, otherwise skip. And here's also a very nice example of how can one could actually use Java, Google Guava library before Java 8. And let's now switch to the front-end part. So I bring up this picture again. You can enjoy the beauty of the interface while I'm drinking water. So let's start with the technology stack. On very top, we used the WebEx UI library. Is anyone familiar with this library? Oh, that's an awesome library. I would really recommend you. So if we basically talk about it, it's all-in-one UI library. So I mean, it provides you all the possible components out of the box. And what is most important for me is that you only do in JavaScript with it. So you don't need to do any CSS and HTML5 voodoo magic. You just write, please, I want to have a column and a couple of rows here, and I don't care how you will render it, and it gives you a responsive interface and everything. So this is quite cool. Another important feature, it's data binding. So if we look into the code, data binding is actually this single line of code. Roughly speaking, it says that we have some kind of form which we bind to device properties data. So from the user perspective, this means if this line is clicked in the table view, the data is automatically goes into the form, and if user changes something here and press the add button, it's automatically updated in the table view. So again, I want to stress this. It's only a single line of code. You you get such a powerful thing, which, well, it's a pity that in our application we do not have a lot of, let's say, editing forms, but I can imagine if you work with electronic documentation and things like that, with electronic document lifecycle where you have to edit a lot of documents, this is extremely powerful thing. So WebEx also provides a promise API, so the promise API is integrated into the WebEx library. Is anyone familiar with promise? It's a very, let's say, modern and let's say powerful thing in JavaScript nowadays. So when you can do all the asynchronous requests like inline them with then and fail and so on. And in code, this looks like this. This is our API, Tango-rest API, built on top on the WebEx Ajax API with the promises. So as you can see, for instance, if we want to perform a GET request, we just say WebEx Ajax get us some URL, and then either it's success or fail. So we provide some predefined failure function. For instance, we can log the error and show a notification to a user, and in success we can also do something. And this call actually returns a promise. So on the client side, they can say Tango-rest IP get and then do something. And the similar thing for put, expect that we can add a header to the Ajax request and put a JSON object into the body. And we can also use a delete method. So this slide is very important. I would like to ask you to remember it, and I will refer to it later. And the last thing is UI components customization. So as I said, WebEx already implements a real huge number of different UI components, but sometimes it's not enough. So you can easily extend the standard behavior. This is code of a logger. So as you can see, it fits on a single slide without really scaling it, just a print screen. And so this is a logger. Main functionality of it is just to log the item. So if it's an error, then also highlight it, then put it into the top of the log messages and throw away the old messages. And this is built on top of WebEx UI list. So it looks like this so let's zoom it. In the UI, here I deliberately provoked a bunch of errors, just killing the backend server, the Tango server. And as you can see, it's very easy to build such things with WebEx. So as I said, with WebEx you don't need to touch the HTML, CSS, and other stuff, so I will just keep it. And on the very bottom we have a JavaScript MVC 1.5.x. Is anybody aware of the JavaScript MVC? Not really. Oh, okay, that's a pity actually, because first of all I would like to stress that this version number, because now if you Google for JavaScript MVC, you will probably, you will end up on the javascript.mvc.com, where the version number is something like 3.9. And this version 1.5, it's actually my branch that I started at 2009, because at that version they provided a very nice solution. So first of all, it was very lightweight because it's pure JavaScript MVC. Oh, sorry, it's pure JavaScript, so no jQuery. So nowadays it's everything on top of jQuery, and this is very good. For instance, if you want to port your application using Cordova on a mobile device, it's much better to deal with pure JavaScript. And also it provides a very well-defined project structure, so you have a dedicated JavaScript file for each entity, like model, controller, view, and so on. Everything is very well organized. It also defines a project lifecycle. So, for instance, you can have a development stage, test stage, and production stage. In addition to this, it provides plugins. So everything in JavaScript MVC is a plugin, and there are plugins for almost anything you can imagine. So cookie, JSON REST, XML REST, JSON P. So whatever is home, usually it's already there. It also provides a testing facility for unit and functional testing. So if your project in a test stage, you have a dedicated console with a list of unit and functional tests. You can run them all or one by one. And for unit tests, it also provides a command line utility. So you can run unit tests from the command line, which means that you can integrate it into the continuous integration process. And it also generates documentation for your project, and there is a lot of other features which I don't want to talk about now because it's another 1 hour talk. So let's have a look at structure of our application. Obviously on top we have a UI, then we have models. This is a very rough structure, and models sit on top of Tango-rest API, which is actually interacting with the server. So with the UI, I already showed you how you can, for instance, implement logger. So here I want to show you how we integrated WebEx with JavaScript MVC, which was a bit tricky. So as I almost said a few seconds ago, you have a different stage of your project in JavaScript MVC, and to perform a transition from the test stage to a production stage, there is an intermediate stage hidden from you, but managed by JavaScript MVC, where it takes all the files involved in the project, loads them into the NAS-horn, so Rina is outdated. NAS-horn analyzes it and then compresses it into a single production.js file with only code that was actually used in your application. So for instance, if there are 100 of plugins and you use only 2, in the end application you will have only code for the 2 plugins. And the problem with WebEx is that WebEx is too complex for this, so we have to skip it during the compression. And in production, we take a WebEx generated from all these files. So here you can see that, so for instance, this is that file logger view, which I showed you a few slides ago. And so everything very well organized in its own file, and when in a development, you just use all these files as it is. And as I said, in production, so this is a screenshot. First we load the WebEx, then we load JavaScript MVC in production mode, and then there are 2 files. So this production.js is what we have for our application. You see it's quite small. And also WebEx, which aggregates all the WebEx components, which are also quite small comparing to, let's say, WebEx itself. And it looks like an ordinary minified JavaScript. So now let's talk a little bit about the models. So as I said, all the models reside in its directory, and obviously we have to map Tango concept in our client implementation. So we have a device model, device server model, and so on. And we also have a Tango host model, which is actually inherited from the cookie model from JavaScript MVC. So the idea is that if user enters the desired Tango host, we store it in a cookie, and for the future interaction with this text field, we show all the all the previously entered values even after the refresh and new session with the browser. And how we implement this, it's basically this bunch of code defines the WebEx component for this text field, and we just say for the suggest component, please give us all the Tango hosts stored in the cookie. And this method is obviously implemented in JavaScript MVC itself. And now finally, I would like you to remember that slide I mentioned before, but if not, it's here. Notice this line. Basically, it's a builder pattern. And for instance, in our device model, we want read attributes, executes commands, and so on. And to read attribute, we just write this very nice and easily readable code. So this IP means tango-rest IP for all devices. Well, I mean for this, from all devices take this device, from all attributes of this device take an attribute of attribute, and then finally give us a value. The same thing for the write attribute, we just use put. So quite elegant solution from my point of view. And now, summary, finally. Or maybe not. I hope you enjoyed it until now. So we have built a very user-friendly and nice-looking monitoring and controlling web application. And as a client, let's say project, completely separated from the server. They both divided by the REST IP, so absolutely independent. And due to the Tango structure mapped into the client structure and the server-side structure, the code itself is quite clean and easy to understand. And also, since we're using libraries, our own code is quite small, but very powerful from the functionality point of view. So it's easy to maintain and support if you know the libraries. And so the name of the talk was Applying Enterprise Technologies in Science. So roughly I covered WebEx, JavaScript MVC, JUGHH REST, and REST Easy. I think these three are really enterprise. Nobody will actually argue with that. But what about Tango-Controls? Actually, it came from the scientific field. And is it really true to call it enterprise technology? Well, in fact, yes, because if we define enterprise technology as a technology that is used in enterprise, there are ongoing projects with Tango. So, for instance, here is a pharmacy warehouse solution for a big client that provides warehouses and logistics services for pharmacy industry. And in pharmacy, it's very important to be really in strict temperature conditions. So 0.5 degree above the restriction or below could produce some problems with the pills, let's say. And if you look carefully, these hacks are actually Tango services, and we can call them microservices. Basically, we have a REST service, which is similar to our, well, it's the same server as we used for the web application. We have a reporting service, notification trigger service, and another bunch of services. And what is important is that we also have a sensor service, which are backed with sensor temperature hardware, and it emits a data flow to the routing service, from where we go to archiving service, so store everything in the database. Then this data can be used to produce some nice looking reports. And from routing service, data also comes to notification trigger service. And if there's some, let's say, a normal behavior or a normal data, notification trigger service can interact with other services which will, for instance, send an email or SMS, or even interact with the hardware through the another Tango server which backed with the alarming hardware like Siren or buzzer or whatever. And another example of using Tango in the enterprise world is that with Tango we can implement Internet of Things concept. So imagine we have a hardware with embedded Linux on it, which runs Tango server, and this hardware is connected to the internet and through the VPN, so virtual private network, is connected to the private network interface of an Amazon instance. And Amazon instance is actually a Tango host instance. Tango host to which we are talking via HTTP from a dashboard application through the REST API, and actually controlling and monitoring this hardware from any point. Yeah, it's just it resides in Amazon cloud. So at this point, I would like to say thank you to all of you for coming. And before switching to questions, I have an announcement. I planned a small interactive session with the WebEx. If anyone interested, are there any interested person? Yeah. Okay. So I think after the questions, we will have a short break for the beer and cookies outside, and then afterwards you'll just surround my laptop and I will show some how to develop a very small but powerful application that reads actual data from the ESRF, so the synchrotron in Grenoble. So let's switch to the question session. And while you are asking questions and I'm answering, you can write down the links. So any questions? Everything clear, I think. I turned it on already.
Okay, I tried to speak loud enough. Okay. I noticed that you always talk about HTTP. I think this is our sensitive devices, and do you protect them via TLS or something like that?
Well, actually, it's just let's just give you a rough concept. So we have something coming from the internet. In fact, the installation of the REST API at ESRF Grenoble, they use a reverse proxy which encrypts all the traffic. So you have to actually use HTTPS to access REST API. Any more questions? Okay, if not the case, then I invite you for. Okay, there is a question. Okay, so the question was about the licensing of Tango-Controls and WebEx. So the Tango-Controls is completely open source, and it's licensed LGPL version 3. WebEx is also provides an LGPL license, but it's so you can have an enterprise license as well, and it will provide you more components. So for instance, you can build charts in a free version, but with a paid version, you can build a range charts. So if you have a long range of data, you can then zoom it and zoom in and out on the data and give this out of the box. And another point about WebEx, it has very nice documentation. So maybe the best documentation I've ever seen before.
You showed a lot of middleware services in your last diagram. Were those all part of Tango or were they custom built?
You mean this one?
Yes, exactly. So routing and notification service, etc.
These are highlighted ones. So these are part of Tango, out of the box. And the blue ones you have, well, I mean, not you, but it has to be developed from scratch.
Okay, and they all communicate via a bus or via HTTP directly?
Via bus, via Tango bus.
Okay.
So the HTTP is only here and here.
Got it, thank you.
Well, another important thing about Tango is that it provides so-called device catalog. So if people write a Tango server for a particular device, let's say camera or motor, and usually in science it's the case that the people order more or less the same hardware from the same vendor, you can go to the Tango website and ask, do you have already a server for this hardware? Usually you can use something that is already implemented.
I have a general question about Tango. Do you know if it offers any particular functionality or it has developed some specific solution using datasets from spatial datasets from satellites?
You mean which satellites? GPS satellites or just some data transfer?
For example, the Sentinel satellite. So they get data from the oceans, for example. They can check how thick is the ice or how much oxygen they have.
Yeah, I got it. No, for now I don't know any such an application.
Maybe just two questions. So first one, is it any limitation for number of hardware which can be read it out?
Using Tango? Well, the only limitation is developer efforts. You have to sit and write the device server, Tango server, which will speak to your hardware and provide all the possible, let's say, in Tango terms, attributes and commands to the client on the other side.
And another question is it all information coming from different hardware synchronized inside Tango, or developer should care about this?
The short answer is that it's not synchronized, so the developer should take care about it, but there are some techniques to use, for instance, event mechanism in Tango, and combining with hardware triggering, you can be sure that things are synchronized.
Okay, thanks.
No more questions? So then I invite you for the soft drinks and beer and cakes outside, and after, let's say, 15 minutes, those of you who are interested in the interactive session, please come to me and we organize it. Okay, thank you very much again.
And perhaps you have some feedback from this architecture, or from some code samples that you perhaps do not like, and you have better, for example, a decision for that. You are very welcome for us to advise us something, for example. Okay, thank you.
too short. Okay, then I'll switch them. So let's bring my laptop. Okay. And now I will need a mouse. The mouse. Well, I don't use Windows very often, so first I need to check whether I have at least JUGHH installed. Test. Okay, it's there. So I've prepared a repository on the GitHub, which we will now clone with some to-dos. Okay, so now let's bring the IntelliJ idea. Sorry? Ah, yeah, really. Okay. Well, in fact, I don't need this repository at all, but let's try again, otherwise we'll continue without it. Okay, so now we have to wait for IntelliJ. Meanwhile, I can show you this huge link is actually reading a value from the ESRF. So if you remember that utility I've showed in the very beginning, so the concrete circle, there are this recipe installed, and we can access it to read some meaningful values. So this actually Currently, it's not very impressive. It's minus something because if we for the operator message, the ring is shut down until the end of this week. But still, we can get this unimpressive values. Okay, now I think we are good to go. Git. Okay, so we will implement very simple application. First we create an index.html where we will load all the libraries we need. So basically it's only WebEx. Link, I think. Yeah, in the README, I copied the interesting links. So WebEx provides a content delivery network, which you can use. So instead of Edge, you can use either a specific version, so we'll get the same version every time, or you can use Edge, it means the latest. And it's extremely fast. I was surprised how fast it is. And then we need script, JavaScript. Basically, it's the same link. Instead of CSS, we just say we want JS file. Then we will attach our application code, which is not yet created, but we will fix that in a moment. And here we will write a simple code. So basically, I want to show what I wanted to show you is to how they read this REST API value, and maybe how to create a chart. And to start with it, let's create a anonymous function. First, we will create a WebEx proxy for the beam current. So beam current is a very important feature of the synchrotron. So it basically says how much energy is in the beam. Here we will simply put this long working. Then we need to create a UI layout for our application. So let's start with something really simple. So we'll just have 2 rows. There. Value will be simply a string. So actually already at this point we can test what we have and fix the errors. Errors expected, it's not a header. Next we want to value from the REST IP. So for this we'll also create some kind of template function. So let's start with the easy thing. We just take a value from the response. So here, notice that all the response from the Tango-rest IP is applied with the value field, with the actual data. And this value is this one. Give it some ID, like the easiest thing is just to load this into the load value into the WebEx using proxy. So we use the special double dollar function provided with WebEx, so you can access the elements by ID within the WebEx structure. Here we pass a proxy, so basically this should be enough to get something. So this is a strange behavior. Usually when you read for the first time from the REST, you get this undefined. Actually we want live values, so what we can do is to define a function. Here we will do this constantly. Let's say every okay. I forgot about the authorization. So actually, to read something, we have to define authorization header. This you can easily find in the documentation. So for instance, if we go to the .com documentation, and oh, that's embarrassing. I wanted to show you how easy it is find to well, okay, I know from the previous experience that there are a number of arguments provided by this function. So there is a mod, URL, and params, something that is called X, and headers. Last one is what we are actually looking for. So headers. Maybe yes. Basically, we are using basic. Kernel knowledge. For the public IP, there is a standard username and password. So now this should work. Value should update every 3 seconds actually, because every 3 seconds they updating it in the ring. Did I provide something else here? Looks like the styles are not here. It should be type and href, right? Yeah, looks like this CSS is missing. Oh, that's strange. This? As it's not allowed. It's the same. Rail style ship, yeah. So. Okay, so should we do anything else, or you're just fed up with it? Hmm? Data is coming from the. Well, I can actually show you the. So it comes from the ESRF. So this facility in France, in Grenoble, which I showed in the very beginning. So remember this concrete circle. So values are coming from there. Maybe just for fun, we can create some chart, dynamic chart, so that will show the values. So all these UI components, you can find them in the documentation. For instance, here you can go to UI chart. So it gives you all a simple example, and then overview, and most importantly, examples. So for instance, we can build the simplest possible chart, and to do this, you can go here and copy paste it. Use, for instance, line chart, so the lines will be, flexible, so not the sharp curves, but rather the. So value again is our value coming from the ESRF, and we want it dynamic, which means that it will get a new value and redraw everything. instance, we want a label, so each point will be labeled with the actual value. Pass a response from the server. Value which is double, and we can show only, let's say, 2 elements after the dot. Then we need to define x-axis. Function takes a response. We want to show a date. From the response, we'll also get a timestamp of the value. So here it is, timestamp, which is seconds since the epoch. Just press it here. Y-axis, we totally rely on Remix. So let's see what we have now. Okay. I actually forgot to give it an ID. In loop, we just want to update this with the value. Let's see. It's better. Okay, that's it. So, any questions? Let me finish with this. Thank you very much for attending. It was my pleasure to share the knowledge about the WebEx, because I feel it's kind of new library and nobody really heard about it before. And yeah, it's very powerful.